All right, guys, so this is lesson 1 for Math 1010. So if I start going too fast, then you can pause and rewind and rewatch things that you don't understand. Make sure right now you have your workbook out that I gave you and you have a pencil in your hand and you're taking notes. Let's go ahead and get started, okay? So lesson 1 has to do with functions, okay? So we're going to come down here where it talks about a relation. A relation is a set of ordered pairs. So you're not going to really have to know that. You're never going to be asked the definition of a relation or anything. So just when you hear it, that's what it is, okay? So let's talk about a function. So basically what a function is, it's no x values repeat. Make sure you write that down, okay? So none of the x's repeat. Every input has only one output, okay? The domain is what comes in, and it's very often the x values. The range is what comes out, and those are very often the y values, okay? So let's go ahead and do example 1. Is this a function? Okay, so do you see this arrow right here pointing to there? That shows that the point starts with a 1 and goes to a 1. So that's 1, 1. This one is 2 and it goes to a 5. The next one's 3 and it goes to a 4. And the next one's 4 and it goes to a 5. Now, you didn't have to write those down, but I'm just trying to show you, what those means. So is it a function? Well, what you do then is you look at these x values, 1, 2, 3, 4, and they're all different. So if they're all different, then yes, it's a function. And then it says if it is a function, list the domain and the range, okay? So the domain, you put a brace and you just list those numbers, 1, 2, 3, 4. Close your brace. Make sure they're in braces. And the order doesn't matter. It can be in any order, but I'd love you to leave it in the order it is. Range is y. So if you look at the second values, we have 1 and 5 and 4, and we have another 5. But if you're writing it in set notation, you don't write it again. When you get your answer, I asked you to get a yellow highlighter. So when you get your answer, you highlight your answer with yellow if it requires work, okay? Okay, question B, is it a function? So if you look here, the x values are 0, 1, 2, and 2, and the 2's repeat, so no, it is not a function, and you're done, okay? The next one, if you look at those x's, 0, 1, 2, 3, they're all different, so yes, it is a function. And then they're asking you for domain and range. So domain is all of the x values, which are 0, 1, 2, and 3 in braces. The range is all of the y values, which are 0, 2, 4, and 6. Okay? Okay, is this a function? So basically the same thing. So do you see how the input is 1 and the output, the input is 2 and the output is 1? That's the ordered pair 2, 1. Input 2, output 2, input 2, output 3. So all those 2's are the same. All these first numbers are the same. And so is it a function? No, it's not. And you're done. Okay? Good question B. So this point right here, you go left 3 and up 2. That's negative 3, 2. This one you go left 2, up 1, negative 2, 1. This one you go left 1, don't go up or down. This one you don't go right or left, but you go down 1, that's 0, negative 1. This one, right 1, don't go up or down. Right 2, up 1, 2, 1. Right 3, up 2. And then look at all these x values, negative 3, negative 2, negative 1, 0, 1, 2, 3. Is it a function? Yes, it is. Done. Now, you didn't really have to list those, and we'll talk about this more. But if you have a graph, the way that you can tell that a graph is a function is that you take a vertical line, like say there, And imagine dragging that vertical line right and left. Does the vertical line touch more than one dot? No. Or does the vertical line touch the graph more than once? No. So if it doesn't hit it more than once, then yes, it's a function. Okay. Question 3. If the point 3, 6 is on the graph of a function, f of x, give the coordinates that you know is not on the graph. Well, if it's supposed to be a function, then the x cannot repeat again. So you could say 3, 2, 3, -5, 3, any number is correct. Don't do 3, number though. Don't write it like that. Just write one possible thing and that's it. Okay? All right. You're going to hear the phrase, something is a function of something. So what I need you to remember is the thing that comes first is the output. And the thing that comes second is the input. Make sure you're writing all this down because your notes will be graded, okay? So it's always output is a number, is a function of the input. What comes in, that's your x, and it's independent. X can very often be anything, and it's not dependent on the y. It just, you stick that x in, okay? And then once you stick the x in, out comes the y. So the y is dependent on what the x is. Like if x is 1, then y is 0. But if x is 3, then y is 5, or something like that. So y is dependent, and it's the output. X is independent, and it's the input, okay? Okay, so let's talk about domain and range. So domain is what comes in. We talked about that. And then there's also practical domain. So practical, you have to think about what makes sense. For example, say you had a domain of -2, -1, 0, 1, and 5. And then let's think that the practical domain that the domain stood for hours. Okay, well, -2 and -1 are part of the domain, but they're not part of the practical domain, because now that we know that the domain is hours, there's no such thing as negative hours. So the practical domain would be 0, 1, and 5. You would not include the negatives because hours can't be negative. Okay, same thing goes with the range. So remember, the range is what comes out. And let's say that the range was -8, -4, 0, 4, and 20. And let's say we found out that the y value or the range stood for pay. And now they're asking you the practical range. Well, -8 and -4 doesn't make sense. This is like you have a job. You're not going to have to pay to have a job. So the practical range would be 0, 4, and 20. That's in money, but you can't have negative money, okay? Okay, so function notation, it's important that you understand that. So this right here is function notation. Could be f of x, g of x, h of x, whatever, but that is function notation, okay? Also remember, f of x is the same thing as y as well. It can be replaced with the y. Okay, so example 4, here's your function, and they want you to find f of 3. Okay, so I want you to write this down. Are you used to seeing f of x, or are you used to seeing f of y? You're used to seeing f of x. So x is -3. So I want you to write this down, okay? If x is -3, what is y? That's what they're asking you. So look at the ordered pairs. If x is a -3, y is a 1. And that's it. And that's literally how you write your answer. F of -3 equals 1. Okay? Let's do the next one. If x is 1, what's y? Well, it's right there. -2. This one, the 5 is not the x. Remember, f of x is the same thing as y. So write this down. If y is 5, comma, then what is x? So they're asking it the other way. So it's this ordered pair. Y is 5, x is 4. So write x equals 4, and you're done. Okay? I'm going to check something real quick. Okay, hopefully I got that whole recording because I don't know, sometimes it does weird things. Okay, sorry about that. So anyway, here's example 5. You're going to have a birthday party. Your parents said you could have anywhere from 5 to 12 people at your party. The cost of the party will change depending on how many people come, and the cost of the party is the function of the people at the party. Okay, so here's what you have to remember. Remember, whatever they say first is your output. So you know output is a function of input. Okay, so the input is the number of people and the cost is the party. And that makes sense. You put in how many people and you get a different cost for each number of people. So the input is the number of people at the party. The output is the cost of the party. Okay, is it a function? Look at the inputs, look at the x's, they're all different. Is it a function? Yes. Why is it a function? I'm going to say no x values repeat. Okay, practical domain. Do you see here how it says you can have anywhere from 5 to 12 people at your party? Right here it says write your answer in interval notation. Actually, I want you to cross that out. Here's why, okay? Make a brace and go 5, 6, 7, 8, 9, 10, 11, and 12. And then I want you to come over here and go 5 to 12. This right here is wrong. You would actually do a bracket because it includes the 5 and includes the 12. Don't worry too much about that right now, but those are technically supposed to be brackets. My point is this. If you do interval notation like that, then you're saying that you can have 5.5 people or 6 3/4 people. It's everything in between 5 and 12. So let's write that down. Everything between 5 and 12. And then I want you to write that that is wrong. That is not the answer because you can't have 5.5 people. This over here means just 5, just 6, just 7, just 8, etc. And that is the correct way to write it. And let's write a little explanation. So I'm going to say only 5, 6, 7, 8, 9, 10, 11, 12, nothing else. So that's the right one, okay? Practical range, same thing. So it's going to be 85, 92, 99, 106, 113, 120, 127, 134 in braces, okay? That's your answer. It is not from 85 with a bracket to 134 with a bracket. That is wrong because that means like 100 would be included in there, but 100 is never going to be a cost for the party regardless of how many people come, okay? Okay, question F. Give a value of x that would not be part of the practical domain. Well, look at the practical domain. You could list anything that's not one of those numbers, okay? So an example would be like 4 or -10 or 100. It's not listed, okay? Explain, and I'm going to say there can only be between 5 and 12 people at the party. Okay, so I think this next line right here, I think there's supposed to be a return in between there. Like, I think this is a different thought, but it's fine. So f of 10 equals 120 means, remember, if x is 10, then y is 120. And you can see that right there. If x is 10, then y is 120. 10 is the input and the independent, and y, or the 120, is the output and the dependent. Write your own statement using function notation, using the table, the data in the table. So let's use 585. So you could say f of 5 is equal to 85. You could do 6. 6 was 92. So f of 6 is 92. You could do 7. If x is 7, then y is 99. And you could keep going. Of course, you don't have to. You only have to list one. So I'm just going to highlight that one and I'm done. Okay? Could it ever be possible for it to not be a function? Okay, here's the explanation, guys. Look. X stands for people. Y stands for cost. Okay, so people and cost. If it's not a function, then that means the x's repeat. Well, if I did 585, 585, that doesn't make sense. I'm listing the same point twice. That's pointless. So it would be something like 597. Well, that doesn't make sense. Because if you have 5 people at the party, is it 85 or is it 97? They can't charge you 2 different amounts. So which one is it? Okay, so is it ever possible for this not to be a function? No. Why not? And we're going to say every input, so every number of people at the party has only one specific cost. If you had 2 costs for the same number of people, then it would be a function, but that doesn't make sense. Okay, so that's it. Okay, so now that you've watched the video, you're going to do your homework. Just to review what we talked about in class, doing the homework involves 4 things. First of all, you have to log back into MathXL. Okay, I gave you a paper during class that said required work. So you're going to open up MathXL, you're going to get a couple of pieces of paper and a pencil, and you're going to start doing the problem. You're going to keep an eye on those problems that require work, and only those problems that require work. Remember how I showed you to fold your paper and then work down and highlight as you go? Those problems are going to be listed on the required work. Don't put anything else besides those. You're going to have a second paper. This second paper, you're not going to give to me, and you're going to do any kind of computing that you need to do for the problems that don't require work. Okay, so now you've gone through all of MathXL and you've completed that assignment. You've done only the required work on this one. This one is for the others. Now remember, like I showed you in class, you're going to use Genius Scan, and you're going to scan that in, and you're going to call it assignment 1 work, and maybe write it Math 1010 assignment 1 work. Then after you scan it into Genius Scan, the last step is to go into Canvas, click on modules, go down to where it says required work for assignment 1, and attach your scan and submit it. Okay, that's it. And then you're going to repeat whenever you learn a lesson. You're going to go through those things for each lesson. Okay, guys? Thank you.